Hello, so this is A-Level Maths Tutor UK, and in today's video, we're going to look at the laws of logarithms. So obviously we've seen the laws of indices before and how we can use the laws of indices and surds as well to solve and simplify problems. So we've looked at logarithms recently in the past few videos in this A-Level Maths, pure maths series, and also in the exponential and logarithms playlist that this video will be in. So today is going to be about proving and actually stating the laws of logarithms that will be useful in our maths education. So let's start with proving the first one. And the way that I'm going to do this is just demonstrate where it comes from and then state the result afterwards. So the idea of your first law is you're going to let a to the power of x be equal to b, and a to the power of y be equal to c, where b and c are just some random numbers. So first of all, we're going to times these two things together. So we're going to do a to the power of x times by a to the power of y. And then what we can do is just use our laws of indices, because when we times indices, we add the powers. So we get a to the power of x plus y there. And this must be equal to that number times by that number, because obviously we're multiplying the two numbers together. So that's going to be equal to b times by c. So we get this here. Okay, so what happens if we take a logarithm of base a on both sides of this equation here? So logarithm base a on both sides. So if you were to do that, we know that what would happen on this left-hand side here is that this left-hand side would become just x plus y. So why would that be? So again, let's think about this. Logarithms are the power that you raise the base by to obtain the number inside there. So what number do you need to raise a by? What power do you need to raise a by in order to obtain a to the power of x plus y? Well, that's going to be x plus y. So yeah, that would be the left-hand side there. And again, another way you can think about it as well, the logarithm of base a is the inverse function of the exponential of base a. So therefore, you just get your input into the exponential function as your output there. Because obviously, again, if we just remind ourselves, applying an inverse function onto a function just gives you the variable that you're inputting into the function. So we've got that x plus 1 on the left-hand side. Then our right-hand side is just going to be still this log base a of bc. We can't really do much with that. Okay, so we've got that result there. So we know that x plus y is equal to the log of base a of b times by c. Now, what we want to do now is just look at these two equations here separately. So I'm going to call this number one here. I'm going to call that number two there. So we just focus on number one first. So from number one, a to the power of x is equal to b. So what we can say is that the log of base a of b must be equal to x. So what power do we raise this a by to obtain b? Well, it's obviously x. So logarithm of base a of b is x. And we can also say from the second equation that logarithm of base a, so we've got a base number of a of c, is going to give us this exponent of y there. So we know that to be true as well. So what happens if we add these two equations together here? So if we do the first one plus the second one, well, if we do log of a b plus log base a, sorry, log base a of b plus log base a of c, well, we get x plus y, so we get x plus y. But what do you notice? So we notice that x plus y is log base a of b times c, but we just arrived at this conclusion here that x plus y is also log base a plus of b plus log base a of c. So therefore, we get our first rule. So rule number one is the log of base a of two numbers times together, so b times c, is equal to log of base a. So let me just try and move this this line up there a little bit upwards. So log base a of b in addition to log base a of c. So that's our first rule of logarithms, and I'll put a green box around that one. So that's the first rule that we need to learn in the A-level maths course. Let's go to look at the second rule. So I just put a bracket around there. That's our first one. So let's look at this second one. So again, this is a very similar rule. So instead of actually multiplying the indices together, in this rule, we're going to look at what happens when we divide these indices together. So let's do a to the power of x divided by a to the power of y. So that's going to give us, using our laws of indices, a to the power of x take away y. And that's going to be this b divided by c, so just b over c there. So that must be b divided by c. Okay, so we got that. Now, what happens if we take logarithms of base a on both sides? So again, take your logarithm of base a on both sides. So this on the left-hand side, and then this on our right-hand side, b over c. So again, the left-hand side, what power do we raise this a by to obtain a to the power of x minus y? Well, the power there is x minus y, so that's going to be x minus y there. So that's what we get there. And then obviously we can't really do much with this left-hand side. That is what it is. So log base a of b minus c. So we know that x take away y is that there. So again, we're going to do a very similar thing to what we did before. So what we did before was you consider the two starting equations that we had there, 1 and 2. So again, I'm going to call this one number 1. I'm going to call that one number 2. So what 1 tells us is that the logarithm of base a of b is x. And again, what number 2 tells us is that the logarithm of base a of c is equal to y. So what happens now if we actually take these results away from each other? So if the first one take away the second, well, we get x take away y is equal to log base a of b subtract log base a of c. So we've got this result here that x take away y is that, but we also know from up here that x take away y is that there. So actually now we get our second rule is that that is equal to that. So let's take this down here. So rule number 2 is that log base a of b divided by c is equal to log base a of b take away log base a of c. So when you divide, when you take the quotient, so the word quotient, if you ever hear me say the word quotient, quotient just means the division of two numbers, the fraction of two numbers. So the logarithm of base a of the quotient of b and c is log base a of b take away log base a of c. So when you divide two numbers and take a logarithm of that, it's the same as taking the logarithm of the numerator and then subtracting the logarithm of the denominator. So that's our second rule there that we've just determined. So now let's go ahead and try and look at our third rule. So with the third rule, what we're going to do is we're going to let a to the power of x be equal to b. So what we can do now then, we can just state a fact. And again, we know that this is a fact here, that log base a of b must therefore be equal to x, just by using the definition of what a logarithm is in the first place. So log base a of b is x. What I'm going to do now with this equation here, the original one that we started with, is I'm just going to raise this to a power of n. So I'm going to do a to the power of x all to the power of m is equal to b to the power of n. So I'm just going to raise both sides to the power of n, where n is just some random number, where n is just like a real number. So then what we can do is use our laws of indices here. So we can say, well, that means that a to the power of x times n is equal to b to the power of n. Okay, so we know that. And now what I'm going to do now is take a logarithm of base a on both sides again. So if we do that, so log base a on that side, and then a log base a on that side, b to the n there. So then if we do this, let me just move my writing up like this. So if we do this, what we will get, so on the left-hand side, what power do we need to raise a by to obtain a to the power of x times n? Well, that's just going to be x times n, because again, the logarithm of base a is the inverse function of the exponential of base a. So we just get the variable x times n, so we get x times n there. So x times n is going to be equal to log base a of b to the power of n. So log base a of b to the power of n. So therefore, what that means, we know that this x here is the same as log base a of b. So let's just plug this result into this result here. So we know that x is equal to that there. So therefore, what that tells us is that this n there times by log base a of b, which remember, this is the same as x. So I'm just swapping x with this here. So n times by this log base b. Sorry, let me get rid of the, actually, no, I'll leave the brackets there, yeah. So log base a of b times by n is equal to log base a of b to the n. And so therefore what that tells us is it tells us that, it tells us just the result here. So it tells us that n, our third result, that n times by log base a of b is equal to log base a of b to the n. So I mean, this one here is actually a bit it's a bit self-explanatory really, because again we know that the power that we raise a by the power that we need to raise a by to get b to the power of n, well that's going to be n times the number that we need to raise the power that we need to raise a by to get b. So I mean it's kind of a little bit intuitive, that one, but yeah, that's how you would prove this specific result here. And then we'll go on to our next one. So these are two not necessarily laws of logarithms, but two rules that will be useful. So the log of base a of a, well, that's just the number 1. What power do you need to raise a by to get a? Well, that's just 1, because a to the power of 1 is just a. So that one is always 1. Well, I mean, assuming that a is not equal to the number 1, we'll just make a note that say that a does not equal 1. Sorry, 1, sorry, that should be 1 there. Then this is true. If a is bigger than 0, not equal to 1, then yeah, this result there is true. And then log base a of 1, well, that's going to be 0. What power do you need to raise a by to obtain the number 1? Well, 0, because a to the power of 0 is always 1. Apart from the number when a would be 1, because again, a to the power of, if a was 1, then 1 to the power 1 is 1, but 1 to the power 0 is also 1 as well. So that logarithm is a bit ambiguous, but in all other cases, log base a of a is 1 and log base a of 1 is 0. So there are two facts there. And then there's one more which we're going to try and derive as well, this last one. So we're going to let sorry, I don't know why I've written we know that here. Oh yeah, and I see, yeah. So we know that if a to the power of x equals y, then we know that obviously that means that x is equal to log base a of y, just using our definition of logarithms. So what I'm going to do now is I'm actually just going to rewrite this a. So remember, if you've seen the video a couple of days ago on converting different exponential bases into a base of e, remember that we can write a number a different from e as e to the power of ln a. So that is the same. So this e to the power of, so for example, the number 3 is the same as e to the power of ln3, or 2 is the same as e to the power of ln2. So we can rewrite this as that. So what that tells us, therefore, is that a to the power of x, let me just write this again, a to the power of x is equal to e to the power of ln a all to the power of x here. Okay, so we've got that. So then we can actually just expand the brackets, because we've got we can use the laws of indices. So this is e to the power of x ln a, and this is going to be equal to still y. It's still the same as y, because we've not changed that number there. It's still y. We've just rewritten the base in terms of a base of e instead, so still the same result. So what I'm going to do with this equation here is I'm going to take logs of base e of both sides to get rid of this exponential base e there. And remember, we just write log of base e as ln to save time and be lazy, essentially. So we're going to apply ln to both sides, the log of base e to both sides, to ln of e to the power of x ln a equal to ln y. And if we do that, so what power do we need to raise e by to get e to the power of x times ln a? Well, that's just obvious. That should be just the power there, so x times ln a. So x times ln a is equal to ln y. So that means, therefore, that x, if we divide both sides by ln a, we get x equal to ln y divided by ln a. So what was x in the first place? Well, in the first place, x was log base a of y. So actually we get our final rule, which is a very useful rule, is this one here. So so our final rule, number 6, I'll do this in red, and it's that, so log of base a of y, so this x there, is equal to ln of y divided by ln of your base, which in this case is a there. So that's our sixth and final rule there. So our first one was the addition rule, so the multiplication rule. When you take the log of the product of two numbers, that's the log of the first number plus the log of the second number in the multiplication. Our second log rule, when you take the log of a number divided by another number, that's the log of the numerator, subtract the log of the denominator. This rule here, when you take the log of a number to the power of n, well, that's just the same as n times the log of that number. So that's another rule that we did. We've got these two rules here. So log base a of a is just the number 1, and log base a of the number 1 is 0. And this final one here, log base a of y, is the same as the natural log of y divided by the natural log of a. And in fact, this rule is actually true. You can prove this rule for any general base, regardless of whether that's a base e there. So this is actually true if this was a log base, let's say base b of y divided by log base b of a there. So regardless of what base there is the base, this is going to be the same as log base a of y. So yeah, it's generally just more useful in maths to use the ln conversion there, just because we normally use ln's most of the time, or a lot of the time in maths. So but you can actually use any other base if you want to as well. So this is a summary of the complete laws. Instead of using A's and B's and Y's and C's, well, I mean, I've used Y's here and some A's here, but I've generally just wrote them in terms of X and Y's here as like a final summary. So this is just a summary of all the laws. So again, our product rule, log of the product of X and Y is log of X plus log Y. Log of X divided by Y is log of X, take away log Y. Log of Y, sorry, X to the power of Y is Y times log of X. Log of base 8 of A is 1. Provided that a does not equal 1, because again, if we think about it, I'll just do a note on the side here, log base 1 of 1, well, could be 0 because 1 to the power 0 is 1, could also be 1 because 1 to the power 1 is 1, so this is not properly defined, so it's not defined, so we don't need to worry about that one, but every other a there, this is true, and for every other a, this is also true as well. Log base a of 0 is oh, sorry, I've made a mistake. Sorry, this is wrong. This is wrong. Forget this. This should be log base a of 1. Sorry. So what power do you need to raise a by to obtain the number 1? A to the power 0 is 1. So log base a of 1 is 0. So that's your rule there. And then this one here, log base a of x is just the same as ln of x over ln of a. And in fact, if you just choose a general base b, as we just mentioned a minute ago, so log base b of x divided by log base b of a is just exactly the same as log base a of x. I mean, it doesn't matter what base you have, this result is always true. And you can prove that just by using the same argument as we did here with the e's, but just changing the e to a base of b instead. That's all you would do with that one there. So again, yeah, that was a summary of the 6 key rules of logarithms that you need to know. And yeah, if you can learn those rules and understand those rules and understand where they come from, then yeah, you should be fine with these logarithms in your A-level exams.